Thank you everyone for joining the Fireside Chat with Anthony Goldbloom, CEO of Kaggle and amazing entrepreneur. Anthony, do you want to go ahead and introduce yourself
Yeah,
to folks?
yeah, sure. I'm Anthony Goldbloom. My career started, my academic background was econometrics and statistics. My first job out of college was working for the Australian Treasury, and then before that, and then after that, the Reserve Bank of Australia. And then in 2010, started Kaggle, which started out for those of you who don't know it, started out as machine learning competitions where a company would take a data set, put it on our website, and people would compete to build the best algorithm. And then over time has become, we do more than competitions now. We have a hosted Jupyter Notebook product, and we also have a place where people share data sets with each other. And finally, for those who are new to Kaggle, we also have micro courses, just very, very short 2 to 4 hour courses that sort of introduce basic data science topics so that, after completing a few of those, you can participate and engage in the Kaggle community. So that's a quick summary of my background and Kaggle.
Awesome. What got you to start Kaggle?
Yeah,
what was kind of like your aha moment to get that going?
I think there are a few with the econometric modeling I was doing. It's really forecasting inflation, unemployment, and GDP and things like that, things that a central bank and a treasury department care about. And I was always interested in more automated techniques, like machine learning type techniques, to train some of these models. Actually, it was the word at the time was data mining, which in computer science was considered to be like a legitimate field of study, and in econometrics was considered to be a pejorative. That if you were data mining, you weren't, you needed to start with an understanding of the relationships, and then you test whether those relationships are real. So I became interested in applying quote unquote data mining or machine learning techniques to some of the problems I was working on, and then through that kind of got introduced to the whole world of machine learning / data mining. Learned about the KDD Cup, which was an academic challenge that the KDD conference used to run every year. And the KDD, for those who don't know it, it's an applied, call it machine learning conference. And they would, you could, like most academic conferences, you could submit a paper as your application, but they also had another way to get a speaking slot, which was to win a competition that they would host every year. And it was quite the competition had quite a following, and I always thought that was a very elegant way to decide who could get to speak at this conference, perhaps a little less subjective than submitting a paper for review. So I was very interested in bringing that idea, having that idea kind of exist beyond, this one particular conference, but rather be something that, for instance, companies and governments and so forth could leverage as another way to get their problem solved. And so that was the very early, the very starting point of Kaggle. So what I would do is I do my day job at the Reserve Bank of Australia. My wife was an M&A lawyer, so she would work very, very long hours. So when I finished between 5 o'clock, let's say, when I finished, and her getting home from work, say that was 10 o'clock, I'd be coding up Kaggle, and that was how it kind of got started.
That's amazing. Great story actually for how it got started. And for everyone else who's just joining this session, just want to say welcome. This is a fireside chat that doing with Anthony Goldbloom, who's CEO of Kaggle, CEO founder of Kaggle, and just an incredible entrepreneur and community builder. And personally, kind of Kaggle's journey that I've personally just followed and love to kind of see how that community grew. And I guess Anthony, question for you is, was that community something that you always envisioned as part of Kaggle, or how did that community start?
Yeah, I mean, the beginnings of the community were I think I created the first competition myself. It was to predict the voting matrix for the Eurovision Song Contest, which is not well known in the US. It had a big following in Australia and in Europe, but it's called it American Idol for Europe, where every country is allowed to vote for every other country. So there are interesting statistical patterns in the voting patterns. So that was the first competition. It had 20 teams enter, and maybe a fun story. The winner was a young Slovenian undergraduate, and he has subsequently become quite a. He got his PhD in Jan LeCun's lab and has subsequently become quite a well-regarded machine learner in the field. So
Wow.
he was part of that cohort of 20 that entered the first competition. And that was a pattern for the first few competitions. I would create the competitions myself, and then people would participate. And part of the idea behind this is that for any two-sided market, the wisdom is, I think I didn't know the literature on it so much, but intuitively this made sense. You need to build one side before you can build the other side of the market, right? What company is ever going to post a problem if you don't have any data scientists? What data scientist is ever going to compete if you don't have any problems out? And the convention, the literature on two-sided marketplaces is you start with the side that is, you build up the side that is easiest first. And for me, that was the community side. And so started out, I would create my own problems, and then started speaking at conferences. There was a conference at the time called Predictive Analytics World. I'm not sure if it still exists, but that was really companies applying these sort of techniques to business problems, and that was how through speaking at conferences like that was how I got my first few customers, and then with any two-sided marketplace, hopefully if it's working out, the two sides start to grow. One advantage actually Kaggle had is a challenge with two-sided marketplaces is you need to keep them roughly in balance. That was less of a challenge in the Kaggle case because it isn't one-to-one matching, but rather it's one-to-many. And so we always found that the data scientist side grew faster than the side posting competitions. But all that meant is that while the first competition was 20 teams, now it's often well over 1,000 teams entering a competition, but it still works, right? It just means we have a high number of participants per challenge.
That's amazing. I think that what you guys have really done is it's the world's largest community of data scientists. And when you think about Kaggle, I think about competition, but really the community is probably one of the favorite things that I think about as part of that Kaggle ecosystem.
Yeah, totally. And I think, as I said earlier, there's much more to Kaggle than competitions now. There's the hosted notebook, and then there's the data sets. And one really nice thing is if you work on a problem, whether it be a competition or one of the data sets that are shared, you're not just working on it in isolation, but you have the opportunity to see how others get feedback from others on your approach, see how others tackle similar problems. So it ends up being, we're very much motivated by a learning by doing type of, giving people learning by doing opportunity. Yep.
So, Kaggle really is focused on, I guess, the data scientist kind of persona. Have you seen folks try to take those models from Kaggle and try to bring them into production? Any insights or anything that you've seen as they've tried to go from that competition mindset to maybe productionalizing it?
Yeah, I mean, certainly it's at the end of a challenge, some hosts use the challenge mostly at the competition, mostly to get a rough sense for what sort of techniques work well on their problems, and others have a goal of productionizing more directly. It is always a huge lift to get models into production at the end of a competition. I think for a few reasons. One of them is that very often the code is not very clean code, right? It's written really in the spirit of experimenting very quickly. Secondly, I think probably a lot of folk in the Kaggle community have more experience training than productionizing, and so they're really designing with, and also the objective is accuracy, right? So that people are designing their algorithms with a view towards getting the highest score, not a view towards what is going to be easiest to deploy or maintain. So it has always been a challenge at the end of a competition to get models into production. Zooming out, this is definitely a big area of focus, among industry. A lot of companies taking different approaches to helping to get algorithms into production. I'm an investor in a company called Orchest that allows you to productionize your Jupyter notebooks, which is a very nice approach. Then you also have tooling that makes it easier. Yeah, like, I guess a lot of tooling is trying to make it easier for data scientists like Orchest to productionize their own machine learning rather than having to go through a machine learning engineer to get those algorithms productionized. And so hopefully some of these products reach maturity and get to a point where it really does become much easier to get algorithms into production.
Yeah. What do you think, this is maybe another insights thing from Kaggle. What do you think separates the winners of the competition from those who don't win? Like, is there any best practices that you see folks doing?
Yeah, I think the answer to this question is perhaps more on the softer skill side than one would expect. But I would say three core characteristics. Firstly, you have to have like some baseline statistics / coding / machine learning ability. So that's one. But once you get beyond that baseline, what separates those who end up doing very well is first of all, tenacity. You enter a competition and you finished 500th. You have to have, I guess, both the combination of curiosity and tenacity to really understand what the winners did that you didn't do, so that the next challenge, you come back and can try what they did. And then maybe even beyond that, beyond curiosity and tenacity, there's also extending on the tenacity theme, even within a competition, you're coming 500th and you need to, keep finding the motivation to try more things, to keep experimenting. And maybe you've just run 20 experiments and they all failed. And how do you push through and do the next one? So that's definitely a big one. And then I said this before, but curiosity is a good one. So very often you have to do something to do well in a challenge that is different from what other people are doing, right? And so we often see people trying really clever things, whether it be feature engineering tricks or data augmentation tricks or different ways to combine algorithms together. Those are some of the key characteristics I think we have noticed in really top performers.
Got it. That's super interesting, and probably not the answer most people expected. Probably expected some kind of mathematical, technique. So that's super interesting. Anthony, let me maybe back up a little bit, and outside of kind of just Kaggle, you've been in the ML space for probably over a decade plus. What do you see as kind of some of the big trends in this space? I think we were just talking right before this about some of the trends of more folks deploying and kind of, and machine learning going more real time and going into production. But what are some of the big trends that you've seen as you've been in this space, and where do you think the space is going?
Sure. So maybe if I look at on the what models are capable of side, the deep learning revolution really all started with image recognition, right? And so I look at image recognition as the most mature use case for I guess the new age of machine learning that from my perspective really started with that miracle results in 2012 with ImageNet. Then you started getting developments in speech, and then with transformers in 2018 and BERT, you started getting developments in natural language, and so we are starting to see deep neural networks really have a huge impact on quite a range of modalities. Still, at least in the Kaggle setting, where you're typically not seeing the most humongous data sets. there's still some of the older techniques like gradient boosting machines are doing very well on structured data problems. I do think when you have very, very large structured data sets, places like Google and Facebook and so forth, you do see deep neural networks doing very, very well on larger structured data sets. So yeah, there's this open question around, can we start to see deep neural networks doing well on smaller structured data sets as well as one breakthrough that's yet that at least we are yet to see within the Kaggle community. A second area of interest, certainly of keen interest inside Google, is this idea of multimodal training. The idea that let's say you're trying to do speech recognition, and you can hear, you're the Google Assistant, for instance, or whatever it is, you're doing speech recognition, you can hear what is being said, but what if you can include a camera so that you can also lip read at the same time? Might that be, so I think some of the possibilities around multimodal machine learning are definitely an area of excitement. And then on we spoke a little bit about some of the challenges in getting algorithms into production. Definitely seeing much more of a move from machine learning being something you play around with and you get good demo results to more interest in putting these and demand for putting these algorithms into production. And as I said earlier, I think some of the tooling, including Arize as a part of this ecosystem, is starting to mature to a point where it gets much easier to both deploy models, and once they're deployed, have confidence that they're doing what they should be doing.
Got it. Yeah, no, that's super interesting to hear kind of what because you touched on kind of data sets earlier on. I wanted to double click on that because Kaggle, you're right, doesn't just do competitions. They have hosted notebooks. You have data sets in the platform, and how do you see folks actually collecting and utilizing data sets with Kaggle? Do you think that, especially with kind of all this conversation going on around data bias and curating data so that it's more kind of balanced it for certain groups of individuals and communities, do you see conversation like that happening in kind of the Kaggle data sets product?
Yeah, I mean, maybe, so first of all, just to explain how Kaggle data sets work, because maybe fewer people in the audience may have come across it. This is actually, perhaps surprisingly, the largest and fastest growing part of Kaggle. And how it works, you can go to kaggle.com/datasets to see it. We have around about 150,000 data sets on any topic you might imagine. And the way these data sets have come to be is they're basically shared. It's, you go to YouTube to share videos, you go to Kaggle's datasets platform to share datasets with each other. And it really is a very, very large collection of datasets. I think that there are definitely some datasets that have been collected and shared with the emphasis on highlighting issues of data bias and so forth. I actually think perhaps some of the more interesting work that's been done around data bias on Kaggle has been around competitions and challenges. We ran a challenge with a team in Google Brain called the inclusive images dataset, and what this involved was oversampling images from places that typically are not well represented in large image corpuses like ImageNet. And actually, in that particular challenge, what was done is the oversampling. We had a more typical sampling in the training set, but then we oversampled from underrepresented places in the test set, which was quite a clever approach. So we have seen some clever challenges being run that require those in our community to build algorithms that are, I guess, sensitive to bias and aware of potential bias.
Yeah, and I think that there's a lot of research still happening in that space. I think understanding how to mitigate those type of bias is still So kind of an ongoing combo. So I'm super curious as Kaggle data set starts, keeps growing, kind of how some of that will naturally kind of make its way into that data set curation part of the platform. Yeah, and with that, actually, probably a good question for you is anything surprising about Kaggle that most folks you think wouldn't know, or kind of is, you know, something you wouldn't actually know about Kaggle?
Yeah, I mean, the one I said before, I think is certainly top of mind for me. The fact that while we're most famous for machine learning competitions, our datasets platform is the largest and fastest growing part of Kaggle, and I think this really um, uh, uh, where do you go if you want to get, you're trying to try a new algorithm or a new approach? Where do you go to go and get data sets? And I think this is filling the data sets platform is really filling a gap that that a lot of people feel. And we've seen some really interesting use cases for that data sets platform. A lot of people, student projects, very often professors point their students towards that platform as a place to go and get interesting data sets. It's just about, as I said, not a topic that isn't covered on our data sets platform. We also hear of companies when they're conducting job interviews and they can't release a data set
Yeah.
from their own company, they'll go to Kaggle's dataset platform to look for a dataset that looks a bit like a dataset you might work on if you're at their company, is another use case. Actually, some of the surprising ones, I interviewed recently a product manager who used Kaggle's dataset platform because she was trying to convince her engineers to instrument some some feature on their website, and in order to show what she as a data scientist could do if that feature was instrumented, she went to Kaggle's datasets platform, found actually quite a close match for that dataset, kind of mocked up an algorithm / app to demonstrate to the, I guess her engineering lead counterpart, and that motivated that team to actually, create the instrumentation for her. So yeah, some really cool use cases for the datasets platform that I don't think we ever would have anticipated. And it's actually the newest part of Kaggle. We only launched it in 2016. And if you had told me back then that it was going to be, I think at this point, I tweet all our metrics, by the way, so you can look at my Twitter
Yeah.
and you can see the metrics, but I think it's about 10x the size of our competitions.
Wow.
It really is meaningfully larger in terms of engagement on the datasets platform versus competitions.
Wow. I did not know that actually. That is really interesting. Where do you see kind of Kaggle going down the future, and especially the community? I mean, I think one of the coolest things, and I talk about this all the time, Anthony, is I think what you've done for creating that community of data scientists and starting, a place for experimentation and things like that is it has probably been one of the biggest impact it's left on machine learning. Anyone can go pick up a data scientist, pick up a data set, try experimenting with it, put it up on a notebook, share their results, and then open up a competition. It's just so unexpected that folks would kind of gravitate toward that and do it and kind of see that pick up in the ML space. So major props to kind of what you've built and what you and the team have built there.
I noticed there's a comment from a college student who plus one the fact that they go to Kaggle for the data sets for their projects and project inspiration, which I think is something we've definitely heard before. So Shuri, thank you for that feedback. As for what's next, Kaggle has never really been big on having a very large, call it 5 or 10 year vision. What we have tried to do is, you got to remember that when we're a community site, we're not like a it's not like we can just like deterministically, say to our community, you should be interested in this, this, and this.
Yeah.
But rather we need to follow our community community's leads. So maybe before talking about what's next, talk about how Kaggle has evolved from competitions. We used to have, we still do have very, very active forums where anyone participating in a competition actually does a lot of people do a tremendous amount of sharing. What we typically find is very useful tips and tricks are shared. Perhaps not, somebody's secret sauce if they're winning, but there's, really, really, really do have very helpful folk on the forums. One thing we noticed people trying to share with each other was code. So they'd attach a .py file on the forums. But let's say I was using Python 2.7 and you were using Python 3.7 and you had those libraries installed and I was getting dependency conflicts and it was just a big mess. Like we had a hard time. It was just very hard. People weren't really engaging with each other's code. And given that people are there to learn, well, that's a very key motivation. Like you would have thought code is just about the most valuable thing one could share. And so the way Kaggle Notebook started was, it was really just a text box with the run button. That was it, backed by a Docker container. But the thing that it provided was a standard environment. So it just made it super easy for anybody. Any code that you saw that had been pasted into that run button, that text box with a run button, you knew would run if you just, use the same Docker container or match the environment. And massively increase the engagement with code sharing. And then of course, one iteration leads to the next, and that text box with a run button became a fully fledged and I think really nice Jupyter Notebook environment. Then where the datasets platform came from was people would use our notebooks for other data sets, right? So they were supposed to be just for competitions, but we would see people get data sets from other places on the web. And that made us think, well, there's obviously an appetite to use these notebooks for things beyond competitions. And so that's why we started allowing our users to share data sets with each other. The micro courses came from the fact that we noticed the top ranked notebooks were typically had tutorial content in them. But the tutorial content was sort of spread throughout the website. It was really hard to know, which tutorial did you take and what order and so forth. And so the idea was we just put tutorials inside our notebooks in just like a very structured way so that you could follow more of a curriculum and had more of a starting point if you're a new user. So as far as what's next, I mean, we're working through that at the moment, but one of the interesting things we have started to see is that actually a decent fraction of the models that have been shared, the data sets that have been shared on Kaggle's dataset platform are actually model weights. So what's happening is people are competing in competitions and they're trying to share model weights with each other. So I think that one interesting direction for us to explore is, can we make it more convenient for people to share model weights with each other? I don't want to say this is like an announced direction or anything like that, but it is something that we are, that would be an interesting next direction for us. As a preview for what might, something we're thinking about anyway.
Amazing. Well, if it does happen, you heard it here first, y'all.
Yeah.
Well, hey, we're getting close to the end of the session, so I have my favorite question that I've been asking a lot of the panelists. But if we're successful, more and more people are going to be able to learn machine learning, pick up machine learning, and be successful in this field. Any advice for people who are just getting started and who want to learn data science? Any advice from you, Anthony?
Well, you got to set aside my bias when you listen to this advice, but I really like, I think we've done a nice job with our micro courses as a very, very lightweight way to get started with data science and machine learning. Each of these courses is just 2 to 4 hours. And the theory behind this is that in order to get started, you don't need all the matrix algebra and so on and so forth, right? You just want to get in and solve problems and get excited enough. And really, 90% of machine learning problems can be solved without all the matrix algebra. And maybe eventually you get to a point where you're doing advanced enough things and you get stuck, and you keep needing to dig deeper and go deeper and go deeper. And eventually, maybe you will learn all the math. But don't let that get in the way of you getting into this, what I think is a really unbelievable field. And I think 90 to 95% of the problems that you're going to encounter can be solved without matrix algebra. So yeah, come to Kaggle's micro courses, do a micro course or a couple. It'll only take you 2 to 4 hours, and then try and dedicate maybe an hour a day to tackling it, whether it be a Kaggle challenge or a data set. And before you know it, you'll be, particularly if you compete in the challenges and you get to see what others do on the same problem, you'll be surprised in a 6-month period, you'll be a very, very, very proficient data scientist.
Amazing. Well, Anthony, thank you so much for being a part of Arize Observe. A lot of our sessions have actually been really focused on the production side, and so it was really nice change of pace to kind of hear from you and kind of where Kaggle is, which is a little bit more upstream in that pipeline. And so really appreciate you being a part of this. If anyone in the audience has any questions, comments, or just wants to say hello to Anthony, feel free to drop a note in the Arize Slack community and available for any questions. Thank you so much, and we'll see you at the next session.
Thanks.